Section 4.2 is talking about addition and subtraction, but it talks a little bit about the flags also. Let's get into it. Let's begin with the increment and decrement instructions. In every high-level program you wrote after you learned anything about for loops, you were doing things like this. Now, you probably learned it before for loops. Same idea in assembly. The increment just means add 1 either to this memory location's contents or this register. Which brings us to over here. The increment and decrement instructions work with either registers or memory. And notice it's any kind of registers and any kind of memory. Same way with the decrement instruction. This is what it looks like in high level. This is what it looks like in low level. Again, we can take 1 away from a location's contents. We can take 1 away from any sort of register. And start getting used to thinking in terms of what flags get affected by these different instructions. Both of these affect the overflow flag, the sign flag, and the zero flag. We're going to be talking more about flags in just a little bit. Which brings us to the addition, subtraction, and negation instructions. We've got a wide variety of ways that we can add things together. All types, register, memory, or immediate. The negation works with either register or memory. Here's a couple of things to remember. The operands must be the same size, and you can't use an immediate operand as a destination. In other words, look over here. Nowhere over here do you see an immediate operand because you can't change something that's a constant. Something else about the negation instruction, it's really doing 2's complement for you. And once again, all 3 of these affect the carry, the overflow, the sign, and the zero flags. I really used to enjoy playing sports, but I've got to say track was my favorite. If you know anything about the long jump, you know that if your foot crosses over this takeoff board right here, there's somebody sitting there with a red flag that they raise up to indicate that you fouled. And I don't care if you set a world record, the jump doesn't count. Well, the idea is kind of the same in the flags register. If there's a 1 set for a flag, that means that guy just raised his hand. If there's a 0, that means that flag didn't get raised. So in a way, each bit is just a signal, just like that red flag. So let's work through some examples. First of all, unsigned data. We're working with byte-sized things here, but the principle's the same whether it's byte size, word size, double word size. This is just easier to keep up with. Okay, let's do some addition just like we would in regular math. 0 plus 0, 0, 1, 0, and I get to here. Remember we put down 0 and carry the 1. I have to do the same thing here. Carry the 1. Same thing. And a 1 gets carried out. In that case, I had a carry out of the most significant bit, and that sets this carry flag to 1. That indicates what? Our value should have been 258, but the largest a byte can hold is 255. That tells us that our addition put in a larger value than could be stored. So carry, that indicates to us that our addition result is not valid. What happens if I add 41 and 90? Get 1, 1, 0, 0, carry the 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, 1. And that value is fine. It's 131, which does fit into 1 byte. Again, these are unsigned. So what happened to the carry bit? Well, in that operation, it got set to a 0, indicating there was no carry out of this most significant bit. Let's look at subtraction. Now, I didn't write these in binary because when you subtract in binary and the bottom number here is bigger than the top number, you get into some weird kind of borrowing. You're borrowing 2 each time instead of 1, like in normal math. So I just want to show you what happens. If I tried to take 70 away from 41, this carry flag is going to get set to 1, indicating, oh, you had to borrow, which means the bottom number is going to be larger than the top number. Okay, now for signed numbers. 59 and 70, I'm going to add those together, just like I did before. So this is going to be a 1. This is going to be a 0, carry the 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, 0, and what just happened here? That changed to a 1. Now, a couple of things just went on. First of all, the overflow flag got set to a 1. Here's what it's got to do with. This sign bit out here doesn't count as data. So the last data we've got is here. So this is, in a way, our most significant bit of the data. Well, it had a carry coming out of it, which set the overflow. Now you're going, wait a minute, wait. Why is that overflow? Look what happened. What's my result? A negative number. Remember when you were learning high-level language and you started off and you ended up storing a value that was too big into, say, an int, and then you printed that out? I hope you got a chance to do that. What printed out was a negative number because there was overflow out of the largest data bit, and it overflowed into the sign and changed the sign. You can have overflow either negative or positive. Now, what happened to the carry bit? Well, it got set to 0 because there was no carry coming out of that. All right, let's go to this one. 129, by the way, won't fit into a 7-bit number. The largest 7-bit number you can have is what? 127. Over here, 1, the largest positive, 1, 1, 0, 1, 1, 1, 0, 0. Now see, these do get added together, just like these did over here with that carry coming out. My signed values, both of them were positive. When I added them together, my result was positive. So what happened to the overflow flag? It got set to 0. How does a 0 flag work? We're going to add these two numbers together. 6 plus 250, I get 0, 0, carry the 1, 0. One thing you got to say about binary math, it's not difficult, but it sure can get tedious. And I had a carry coming out. So for this one, a carry came out. So that flag gets raised. Overflow, yeah, that did get set, but we're not going to worry about that for unsigned. It did get set. But for our unsigned stuff, the ones we're going to really worry about are the carry and the 0. Now, the 0 flag, look at our result here. What it ended up being? 0. So this flag gets raised. Coming out here. 1, 0, 1. Nothing to carry over, so that's 1, 1, 0, 1, 0. Look at my result. Is it 0 or not? And the answer is no, so the 0 flag would be set to 0. In other words, 0 is kind of weird. You got to really pay attention. If the result turns out to be 0, the flag gets raised. If the result turns out to be non-zero, like it did here, then the 0 flag gets set to 0. That mixes people up all the time. The sign flag really comes into its importance when you're talking about signed numbers. It gets set on unsigned data too, or cleared for that matter, but it just doesn't matter in those. So I'm adding these together. I should get an answer of negative 12. So 0, 0, 1 plus 1 is 0, carry, and plus 1 is 1, carry the 1. And then these two add together and give me 1. Now, if you figure this out in 2's complement, it comes out to be negative 12. But look what happened to our sign. Whatever our sign ends up being out here, that's what goes in this flag. So since our result was negative, the sign flag gets set to 1. Contrast that with over here. We're adding two positive numbers together. Our sign stays positive, and so this sign bit would get set to 0. This is on page 119. This is really important. Make sure you read that little paragraph a couple of times. We've been talking about signed and unsigned numbers and how the flags get set. And you might be wondering, well, how does the CPU know the difference? And like this says, it doesn't. Remember, all the arithmetic and logic inside a computer is based on switches, either letting electricity flow through or stopping it. And so the flags get set no matter what. You have to decide how to interpret what those flags mean. So why did I go into all this junk about flags? And the reason is, in Chapter 6, we're going to start writing our own if statements and loops. By the way, there is no if statement in assembly. We have to construct our own. That's actually kind of fun. If you have any questions, please get with me. Thanks for watching.